Hello and welcome. I'm doing a quick test solve today. I have to record a new intro because it turned out to be slightly different than what I thought. I thought I was testing the next round of the FMWC UK, or the first round, since the other things that have come out so far have just been previews. A case by Harry Watson. Turned out that Harry was just being extremely diligent because they were testing the FlexiQuiz platform they're going to use for putting the answers in. He wrote a separate case for that. Because I don't know, I guess because he's just very good at writing cases. But anyway, I had a lot of fun playing it. Well, I'll switch back to my live solve in just a second, and apparently lots of other people did as well. So we have successfully managed to persuade Harry that he should release the case anyway. So he has very kindly shared that for free. I'll post a link in the description to where you can get it. I encourage you to give it a go before watching this. Now I'm going to switch back over to my live solve. I will briefly mention both this video and my live solve were recorded in very bizarre light conditions. So sorry about that, but you know, if you've ever watched my channel and then come back, it's safe to say that you're not here for the video production values. All right, let's dive in.
So let's download. And I've got my handy file over here. Okay. Mwah. VDIM. And hopefully I can base, yes, a backup version. Okay. Oh, and I'm going to start my timer, and then I forgot. I don't know if you can see that. I think that's above where my face goes, but it doesn't matter. Oh, I should probably have had Excel open. That would have saved me a little bit of time, but never mind. All right, so. It's not in any hurry to open today. All right. Easy as 3.14159, etc. Let's see. I know out as far as 35, 89793238462. Anyway, Harry Watson. Of course, it's Harry Watson. Pie is delicious and nutritious. To make this game more exciting, 4 bonus questions. If the pi shipped to... Okay, well, we better learn what it is. For each value of n, what is the nth decimal place of pi after the decimal point? Hint, how many different Excel functions do you know that can be used to look things up? Hold on. Oh, sorry. Right, there are. Okay, so it's only done by color. Fabulous. Okay. We'll control F by format. Sorry, no, I want to find format from cell. And we'll replace all of those with, I guess, 1. How many decimal places are there here? Quite a lot. 1,000, I guess. Okay. Anyway, so let's just do a sequence of 1,000. And let's also, while we're at it, do, oops, there we go, sum of, I guess we go out to 10. Hopefully that should give us numbers between 0 and 9, and it does. Okay. So, the nth place after the decimal point. So 5, 1, 2, 3, 4, 5. Okay. That seems to be broken. Okay. I'm going to highlight that. But the rest is fine. Wait, what? Oh, decimal place 227. Yes, fine. So I'm just going to call this PyDigs, and we should be able to then just say index PyDigs, comma, by all of this. Okay. Index PyDigs by 5 is checking out. Oh. Ah, right, yeah, okay, so I guess maybe this whole scoring thing is not meant to be here, which is fine. I wasn't expecting it to be, although, actually, wait, I'm not going to hide it, I'm going to extend the highlight to remind me to tell them that it needs to be hit. Okay. At what point do the following sequences of digits first occur in pi? Okay. So I think we want to concat that. So let's just search 58 in this. And that is indeed 10. Okay, so then I think we can just search each of these in our concated PyDigs. No idea if that's right or not, but it's fine. The pi shift 1. As a follow-on to whodunit, we investigate a new letter shift called the pi shift. In the pi shift, we assign letters a value with a equals 1 up to z equals 26 for each letter. We then look at the value and where this first occurs in pi. The GCD of the value and the first place it occurs. For instance, b has a value 2, digit 2 appears in place 6, GCD of 62 is okay, so b is shifted 2 to d. In each case, encrypt the following words using the pi shift. Okay, so I think that first we just want to say char of, oops, we're all uppercase, I guess, so char of sequence of 26 starting at 65, which is the code of an uppercase A. I guess that's a spill, so move it up a bit. Those are all our letters. Then we can say code of that, and sorry, no, code of that minus 64. Then we can say search of this in concatenated pi digits, and then we can say GCD of, if I do this, is it going to collapse the whole thing? Yes. So then I can say map of this GCD. Okay, fine. So then we want mod this plus this minus 1 by 26 plus 1 will get us back to the letter. So in this case, B shifts to D, yes. And if I make it plus 65 and turn it into a car, that should give me the shifted letters. Okay, so that's the pi shift. So then I want XLOOKUP mid of this by sequence of len of this 1 in here, lock returning from here, lock, and that applies the pi shift. And yes, I just need to concat them back together, but that is it. Okay, and every year to mark the most famous irrational number perhaps in existence. Interesting hedge there. Anyway, the issue with the pi shift is an encrypted message is not always well defined. This happens when the number of pre-images is greater than 1, meaning the letter cannot be deciphered. For instance, F has 3 letters that map to it. For each of the text strings listed, how many other text strings map to them under the pi shift? Okay, so what we need to know is for each output, how many times does it occur? So we'll say countifs. This is this, and that's fine. And then we can say, well, let's just take this. We still want the mid piece. We'll get rid of the concat. That part's fine. That part's going to go. So we're going to look it up in the output letters returned from the counts. Lock, oops, lock. Yes. 211 and NA. Aha. So the answer is 0. Okay. So then if not found, 0. And then product. Okay. Almost all zeros. Okay. Fine, I guess. Multiple pi shift. In each case, we take the given text string and apply the pi shift a given number of times. We now want to know how many pre-images the result has under the pi shift having been applied that many times. Oh my god. Okay. Huh. That is interesting. A pi shift of 5 gives G. 3 letters in total, which yield G after 4 pi. Okay, yeah, so I guess the question is just if we apply it iteratively. So let's take this, put it down below there, and then let's do XLOOKUP this in this returning from this. And I think I'm going to lock both of these. So this is 1 step, 2 steps. Let's just see what's the most number of times we ever want to apply it. And the answer is max 8. Fine. Sorry. Equals this plus 1. 11. Does it eventually collapse? Not sure. Those rows of unique. Probably some of them just cycle around. Yeah. Okay. Fine. So it stabilizes, which is fine. So now my question is, for each of these, I think I just want to know after n pi shifts how many things we get there. So, okay. Okay. So, then I want to mid this again. So I'm going to mid this by sequence of len of this one. Then I want to index this. Yeah, get this right. Index this lock by the row number is going to be. No, hang on. Sorry. First, I need to shift it n times. No, I just need. What am I trying to say here? Okay. So I want to. Yeah. So I just want x match. Right, I don't even need x match. I can just code of that minus 64. That gives me the row number. Okay, and then I want to index on this lock by this is that code is going to give me the row number, and this is going to give me the column number, and that gives me 3. And then this should give me a product, and that's fine. Okay. So let's just break this down a little. So if I take CUN and ING, there are 4 things that can get to U in 4 steps. Sorry, in how many steps? In 6 steps. So in 6 steps, how many things can get to U? T, U. Yes. So 4 letters get to U. Let's just quickly see, can I find 4 U's in here? No. No, I'm not counting it the right way. Okay, so, yeah, I'm counting it wrong. So I need to count what? I need to count this. No, what? That's not good. Sorry, wrong way around. So what I want to count is how many times the original letters are in here. Okay. So now I'm saying nothing maps to A, 3 things map to B, nothing maps to C, and so on. Oh, right. But I do want it the other way around for the encrypted version, so I guess I'll do one of this with this, and then I'll have to replace that in the other question. And spill. Why is it spilling? There's nothing. There's a merged cell somewhere. Yes, here it is. Where'd it go? Bloody merged cells. Why is this even merged? Fine, there we go. Right. Okay, so oops. Hello, there we go. So I'm gonna point that to here, I think. Oh no, I was all yes. I think that's what I want. So THIS gives me 2110, 2 letters map to T, 1 to H, 1 to okay, good. So then here, it's not looking good. Right, because I need to take the encrypted version, okay. Fine. What am I doing? Maybe I had the right formulation before. God, this is getting complicated. Oh yeah. Crud, I think I did. Alright, fine. Let's just try changing it back. Stupid. Anyway. So, sorry, 2, 3, 4, 5, 6. I was looking for 6 things that encrypt to U, but what I want is 6 things that encrypt to what U encrypts to, which is H. So there's 1, 2, 3, 4. I only see 4. Sorry, yes, 4 things that encrypt to what U encrypts to. So that is that. So then product of this 192, and this should never come out as 0 because it's the preimage of something that has been encrypted, so there's always an option. Okay, so I think that's it. Is there a words tab? A wobble word list? Okay, fine. I guess that's for the bonuses. Okay, so if the pi shift is applied indefinitely, we eventually end up in an orbit of letters. How many letters? So I already found that out. Of the words in the wobble word list, how many do not have any pre-image under the pi shift? Okay, so where are we? What I really want to know is what letters have no pre-image. So I want to say, just put it over here, equals countifs. This is this. And then I want to filter this where this equals 0. So if it contains any of Acme, Q, S, V, and Y. Okay, so then, so I want to reduce this by this, lambda A, V, is error, search V in A, sorry, filter A, where is error, search V in A. That should drop all of those letters out and leaves us with 1, 2, 3, 7. Except that wasn't the question, was it? The question was how many have no preimage. So then it's rows of the word list minus rows of the ones that have a preimage. Seems like a lot. Of the words in the word list, how many have a well-defined pi shift? This means that the output of the pi shift on this word has one preimage, which is the word itself. Okay, so then you have to only use the letters that come out exactly once. So here we want to say equals filter this, where this equals 1. And sorry, I guess I want a filter where that is not equal to 1. These are all the ones you can't use. Okay, so the answer is 342. So let's just see. DHOW, for example. D maps to F, another thing is mapped to F, so that is not what the right answer should look like. What the heck am I doing here? Yeah, that's what am I doing? I guess I need a different count for this one, so say count ifs. Where this is this, which I think I already have somewhere else, but never mind, I've committed, I'm going to do it. Then I want to say filter the letters where this is not equal to 1. So A, as an example, is mapped to by, the letter A maps to, which is B, occurs other times, yes, yes. So you can't use A. And likewise, you can't use any of these, fine. So then, here are the words that don't use any of these. So B maps to D, and I guess we're saying nothing else maps to D. Fine. So then the answer is there's 176 unique pre-images. Of the words in the wobble word list, how many have a practically what? Any word whose pi shift output has only one preimage in the wobble word list. Ah, okay. Okay, so then I think I need to just pi shift each of these, which I did somewhere down here. Yes, this is my pi shift formula. I should have named these. Blah, never mind. Case. That still works, okay. So then this, and this. And that's going to take a little while. Okay. And then, can I think of a smarter way? Yeah, probably group by will be a little faster then. Group by this rows. Let's sort. No, don't stop. Don't calculate yet. I want to change the formula. That's annoying. Come on. Yuck. Well, okay. At least it stopped. Okay, then I want to go no totals and sort order -2. Okay, now it will just take a minute to calculate. Might have been better to just do a pivot table actually, rather than having a live calculation, but never mind. So what am I actually trying to say here? I want to say if the answer to this is 1, then we're good. So countifs, this is 1. Really? That seems like a lot. Okay, fine, whatever. My confidence in some of these answers is pretty low, but sorry, I should link. Anyway, all right. I just remembered that I'm supposed to be putting these answers into FlexiQuiz, which I have not been doing at all. So let's do that now. Level 1 code. Level 2 code. I don't feel super confident in many of these answers. I feel like I was shuffling around a lot. But never mind. A lot of zeros here. Is that really right? This is what? Number of pre-images, fine. For each of the text strings listed, how many other text strings map to them under the PyShift? Crossbreeding pi philology, the study of discrete time dynamical systems, riveting stuff. Love it, love it, love it. All right, so the letters that have no pre-images, or what, they're somewhere around here. Where did I put them all? Here. So nothing maps to A. Yes. Yes, fine. So anything containing ACE, MQ, SVY. ACE, MQ, SVY. Okay, so let's see. Y, E, S, yes. I, yes, E, C, E. Alright, lots of zeros, but I guess that's the answer. And level 5. Yeah. Alright, let's close and grab the file and upload. That, am I sure? Yeah, let's say that I'm sure. Ah, look at that! It even tells me my score. Hooray! And I got an A. Alright, well, I wasn't sure about that one, but that was a fun case. I'm not sure if I've lived up to mini case by taking more than 20 minutes to solve it, but never mind. I liked it a lot. What is next going to take me to? Probably the FMWC UK site. No, it's going to take me to some weird ad. Oh, and then back to the round 2 thing, which I don't think is the thing that's meant to be there, but never mind. All right, that's all I got for today. Thanks for watching. See you next time.